Welcome to my channel. If you like my videos, then kindly subscribe, like and watch. Thank you.
Bismillahirrahmanirrahim. Welcome back. Problem 7.32. In this problem, it is given that element under the state of stress, you can see we have sigma x is equal to 150, that is tensile, 150 megapascal. Similarly, sigma y, that is also in tensile, and that is 30 megapascal. And tau of xy, that is minus 80. Why minus? I have explained it in the theory lecture. So you have to find the principal planes and principal stresses. So A is principal plane, theta P1 and theta P2. Clear? In part B, it is given that principal stresses, that is sigma max and sigma minimum. And C is that orientation of plane of maximum in shear, so theta S1 and theta S2. D is maximum shearing in plane shearing stress, that is maximum shearing stress in plane, and in E, that is corresponding normal stress. So previously we solved this problem using transformation equations, but in this problem 7.2 it is given that solve this problem using Mohr circle. So we will solve this problem using Mohr circle. For first we will find the point x and y in order to locate this on this graph. Clear? So as x is equal to sigma x comma minus tau of xy, similarly sigma y point is sigma y comma tau of xy, and C point, which is center point, is equal to sigma average comma 0. So you can see that sigma x is 150, clear, and tau of xy is minus 80, so minus minus plus 80. Clear? Similarly, sigma y is 30 and tau of xy is minus 80. And sigma average, which is equal to sigma x plus sigma y divided by 2. So 150 plus 30, 180 divided by 2 is 90 comma 0. So we will plot this point on this graph. So while plotting this point on graph, so use appropriate scale. I have taken 1 division is equal to 20 megapascal on x-axis, which is normal stress, and on y-axis there is shear stress, and also 1 division is equal to 20 megapascal. So let's plot this points. So for x, 150 and 80. So on x-axis this is 60, 80, 100, 120, 140, 160. So your point will, this will be your 150. Again 80, 100, 120, 140 and 150. Clear? And on y-axis this will be your, this point will be your 80 megapascal. Clear? So this point is x point and this is 150 comma 80, and this is your x point. Clear? Now for y point we have 30 minus 80. So you can see that this is 20, so this will be 30 and minus 80. So 20, 20, 40, 60, 80. So your this point will be y, and this will be equal to 30 comma minus 80, because this is minus 20, minus 40 and so on. And 90 is the midpoint. So 80, this is 80 and this will be 90 approximately. So this is your center point C. Clear? Now what you have to do, you have to join these 2 points x and y that will pass through the center. So you can see now this point is origin O, clear. So OC is average, which is sigma average, that is 90. Now you have to draw a circle keeping this as center and taking the distance C, either CX or CY. So you have to draw a circle using protractor. Here I am going to draw a circle, but I will have to adjust it. Clear? So you can see, sorry, not this. So here it's very difficult to adjust, but I will try my best. It is very easy when you do this by using protractor. Clear? Okay, so we have now this circle. On this circle you can see, for finding the principal stresses, we have sigma max over here and sigma minimum over here. So in order to get the principal planes, so you have to rotate the element to this theta, and this theta is 2 theta p. Clear? On this, so if you rotate it through 2 theta p, so we will get the normal principal stresses. Clear? So first part is to find the principal plane. So for principal plane, if you look that, if I draw a perpendicular from this point, clear, so I will get this. Clear? Now you can see, let this point is point E, this point is your point F, let. Clear? So you can find tangent theta. Clear? And we know that tangent of 2 theta p is equal to this perpendicular over base, which is EX over CE. Clear? I will choose a thinner. Okay, EX over CE. And you know that EX is what? EX is this distance, which is plus 80. So EX is 80. Clear? And this CE is basically, this CE is equal to OE minus OC. OE minus OC. Clear? Now what is OE? So O is this point origin. So OE minus OC is equal to CE. Clear? So OE is 150. So you can see this point is at 150 on x-axis, 150 minus OC. OC is sigma average, which is equal to 90. Clear? And that is given over here. So CE will be equal to 150 minus 19, that will be equal to 60. Now you have this value and this value, you can put it in this formula. So tangent of 2 theta p will be equal to 80 over 60. Clear? So 2 theta p will be equal to tangent inverse 80 over 60. When you solve this, so 2 theta p will be equal to 53.13 degree. Now you can see you have to rotate this x plane clockwise at angle of 53. So theta p will be equal to, this is clockwise, that is, I have not written minus sign. So you can see from this Mohr circle that This is clockwise rotation. So theta P1 will be equal to 53.13 divided by 2, and it will be equal to 26.56 degree clockwise. But if you do not write clockwise, so there will be a negative sign. So this is be theta P1, and theta P2, you know that it is equal to 90 plus theta P1. Clear? So when you put theta P1 is minus 26.1, so theta P2 will be equal to 63.44 degree. Now what does it mean? It means that this is 2 theta P. Clear? So it is actually 53. So remaining will be equal to 180 minus this. So theta P2 will be 2 theta P2. This is theta P1 and this will be theta P2. It means if either you rotate it through 2 theta P1 in clockwise, or you rotate this element or this axis through 2 theta P2 in counterclockwise direction. So you will get the principal stresses. So this was all about part A, that is to find the principal planes. Now we will move toward for finding the B part, that is sigma max principal stresses and sigma minimum. So sigma max, from this Mohr circle you can see that sigma max is equal to OF. Clear? And this OF is equal to OC plus CF. I will show over here OC plus CF. Now OC is equal to sigma average, which is equal to 90, and CF is equal to this radius of circle, that is equal to R, and R can be find. So this is CF is R and also CX is also R. So this R can be found, this is R. So this R can be found by using Pythagoras theorem, that CE square plus EX square. So CE is actually 60 square. This CE is 60. We have here 60. Here, and CX is 80. So 80 square under the root. So this CF or radius of Mohr circle comes out to be 100 megapascal. Clear? Now you can put here, so sigma max is equal to OC, which is equal to sigma average, plus CF, which is equal to R. So sigma average is equal to 90 and R is equal to 100, and that is equal to 190 megapascal. Now we will move towards sigma minimum. So sigma minimum, you can see that this is equal to, let's say this is point D, this point, this is equal to OD, and this OD is equal to DC, this will be equal to OC minus CD. Clear? This point is OC minus CD. Clear? So this point is D. Let me check whether I have taken. Okay, it's clear. Clear? Now OC is sigma average and CD is also radius, because this CY is radius, so this CD is also radius. So that is equal to R. So 90 minus R is 100, so that is equal to minus 10. Clear? Minus 10 megapascal. So we have find out the sigma max principal stresses, that is equal to 190 megapascal, and sigma minimum is equal to minus 10 megapascal. Pascal. So if you want to represent it on transform section, so we can draw it over here. Let this was initial x-axis, this was y-axis. Now theta p1 is equal to, it is theta p1, so theta p1 is minus 26.6. Clear? So we can say that minus 26, let this is minus 26 point, this is your new x dash, and this will be your perpendicular y dash. Clear? And your transform section will be a rotating element at angle of, this angle is minus 26.56. Clear? So we have only principal stresses. So principal stresses in this direction I will show them. So in this is in x dash direction or transform direction, that will be equal to 190, sigma max is equal to 190 megapascal, and sigma minimum will be equal to this one, and that will be equal to minus 10 megapascal. Now let's move toward part C, that is to find theta S1 and theta S2. As we know that from this Mohr circle, so maximum shearing stress will be here. So if we draw a perpendicular at point C, so maximum shearing stress will be at this point, which will be the radius again. So if I take a perpendicular, let me take perpendicular line from this, so I will choose a line, and that from, so this will be your maximum shearing stress, and this angle will be equal to, this will be theta S. Clear? And you can see that this theta S is equal to 90 plus 90 minus 2 theta p1. Clear? So as in element section, we can write theta S1 is equal to theta p1 plus 45 degree. Clear? But in Mohr circle, we can say that 2 theta p plus 90 degree. 2 theta p minus 90 degree is equal to theta S1. Clear? So it's better to remind this that theta S1 is equal to theta p1 plus 90 degree or minus 90. Let me check. I from 1.31. So plus theta plus 45 plus 45. Yeah. Okay. So theta p1 was minus 26.56 plus 45 degree. So this will be equal to theta S1, and this theta S1 is equal to 18.4 degree, and so on. Theta S2 can be found as theta S1 plus 90 degree. There, and that is equal to 90 plus 18, which is equal to 108.4 degree. Clear? So this was part C. Now in part D, we have been asked to find the maximum shearing in plane shear stress. So from this Mohr circle, you can see that this stress is actually equal to radius. Clear? Sorry, not this. You can see, if you have drawn it perfectly, so you can project it as well. But you can see that this radius is equal to the maximum vertical distance, and that is equal to R. There, and R we have find over here that R is 100 megapascal. So maximum shearing stress is equal to R, which is equal to 100 megapascal here, and corresponding normal stress, and that is equal to sigma average. And from also Mohr circle you can see that this is the shear here it will be sigma average, and that will be tau max here. So, as that will be equal to OC. O is this point, clear? So OC, that is equal to sigma average, and sigma average was 90, clear? So that is equal to 90 megapascal, clear? So if you want to represent again our transform section, so let this was your x-axis, this was your y, clear? Now shearing angle is 18.4, so theta is positive, so counterclockwise, so this will be your new x dash, this is 18.4 degree, and this will be your new y dash. Again, this is your y, clear? So transform the rotated element will be look like this. Again, you have to draw it perpendicularly. Now you can see the shearing stress is 100, so it will be like this. This will be the tau max, and that is 100 megapascal. Now corresponding normal stress will be sigma dash, and that will be equal to in the direction of y dash. So it will be like this, and it will be again like this. This will be equal to sigma dash, and that is equal to 90 megapascal. So I hope you have enjoyed the problem and also learned from this problem as well. If you like my video, kindly subscribe, like and watch. Thank you.